Today I'll be talking about motion in 2 dimensions, and that includes acceleration in 2 dimensions. So, first example problem. A ball rolls off a table that is 1.38 meters high at a speed of 0.84 meters per second. So first, we want to picture this. We want to see what's happening. So consider a table and a ball moving so fast rolls off the edge of the table. Now once it goes off the edge, it's going to fall in a parabolic shape and then hit the ground. Okay? So our initial velocity, solely in the x direction, Vx, is 0.84 meters per second. And the height of the table is 1.38 meters high. So now that you have a picture, we can figure out what it wants. How long does it take the plate to hit the floor? Well, that's our standard distance formula. We know distance equals 1/2 acceleration, which is, in our case, gravity, times time, because we're trying to figure out how long it's going to take to hit the floor, squared, plus initial velocity in the y direction, times t, plus initial position. Alright, so let's plug in what we have. We know when it hits the floor, our distance, s, is 0. So we're looking for when this equation equals 0. 1/2, gravity is negative 9.8, t squared. Now our initial velocity in the y direction is 0, because when it leaves the table, yes, it's moving 0.84 meters per second to the right, but it's not moving up or down at all. It's just moving completely to the right. So there is no initial velocity in the y direction. And our initial position is plus 1.38. So we solve this equation. Minus 1.38. And we are going to divide by this. So we have t squared, or negative 1.38 equals 1/2 negative 9.8 t squared. So therefore, if we divide and take the square root, we get t equals square root of negative 1.38 times 2 divided by negative 9.8. So luckily our negatives cancel out and we can actually get an answer to this. So our final answer, time equals 0.53 seconds. That's time it takes to hit the ground. Alright, erasing our picture. How far does it fall from the base of the table? Alright, well we know it takes 0.53 seconds for it to hit the ground. We just want to know how far from the base of the table did the ball fall. So we want to know this distance right here. We know the velocity in the x direction is 0.84. Velocity in the x direction and the y direction are totally different. So we know it's moving at this speed the entire time. 0.84, 0.84, 0.84. Times this time, we're just using distance equals rate times time. Distance equals rate, or velocity in the x direction, times time. So that gives us our d here. So d equals 0.84 meters per second times time, 0.53 seconds. They're both 2 sig figs, so we're going to be using 2 in the end. So we get d equals 0.45 meters. And the last problem. What are the vertical and horizontal components of its velocity as it hits the floor? So we want to know what it's doing down here. It still has some velocity in the x direction, and it also has a velocity in the y direction when it's hitting the floor. Our Vx and Vy. Vx is easy. We know Vx is constant because gravity is not affecting it. So there's nothing affecting it in the x direction. It stays at 0.84 meters per second. The y direction is affected by the gravity, and it started at 0. So our second equation we can use, we know velocity, final, equals acceleration times time. We know this is g. So we can also say g times t plus initial velocity in the y direction. Acceleration is also in the y direction. That's our gravity. So you can put those subscripts. So our final velocity in the y direction, well, we have no initial velocity in the y direction because it's not moving up or down. It just fell off the table. That's gone. So our acceleration in the y direction is just negative 9.8 times the time it took it to fall, 0.53 seconds. So our velocity in the y direction when it hits the ground is negative 5.2 meters per second. And the velocity in the x direction has never changed. This is a constant. It's a constant. So our velocity in the x direction, or final velocity in the x direction, is the same as what it was before, 0.84 meters per second. Okay, second problem. A football is thrown out of the window of a house at 4.2 meters per second with an angle of negative 23 degrees from 2 meters high. How far from the base of the house does the ball hit the ground? So in the end we want to know this distance, d. But we're given the height basically of the window from here to here is 2 meters. And we're also given an initial velocity, so Vi of 4.2 meters per second at an angle of 23 degrees, or negative 23 degrees. Negative 23 degrees. Alright, so that's our initial picture. But first thing we have to find is the initial velocity in the horizontal and vertical directions, because that's what matters. So really we just have this triangle here. The initial velocity given to us is here. 4.2 meters per second. So we want to know the initial velocity in the x direction and the initial velocity in the y direction. That's going to help us out the most. Well, from trig, we know the initial velocity in the x direction of this guy is our angle, 23 degrees. Well, we know the hypotenuse and the adjacent, so that's going to be cosine. So, we know cosine of theta equals Vix over 4.2. So we get cosine of negative 23 degrees, or 23 degrees we'll use, times 4.2. And we'll use that later. The velocity in the y direction, initial, is sine. You can use negative 23 degrees times 4.2. This is the one we're going to be using immediately. So we need it. VIY equals negative 1.6 meters per second. Now we have a few steps here. First thing we want to find out is how long it takes for it to hit the ground. So we use the traditional distance formula. S equals 1/2 gravity times time squared plus initial velocity times t plus the initial distance. Okay. So we just plug in what we have. We want to know when it hits the ground. So our final position is 0 equals 1/2 negative 9.8 t squared. Our initial velocity in the y direction, and that's what we're talking about here, is all y direction. Gravity is in the y direction, velocity is in the y direction, is negative 1.6. So minus 1.6 t plus initial position is 2. So from here we can use the quadratic formula. We're going to know t equals negative b, so negative 1.6 is plus 1.6, plus or minus the square root of b squared, so negative 1.6 squared minus 4 times 1/2 of 9.8 is negative 4.9 times 2, all divided by 2a. So 2 times negative 4.9 ends up being negative 9.8. And we only want our positive answer from that. So once we do all the work, we get a time of 0.50 seconds after rounding to sig figs. So we're finding this distance, and we know velocity in the x direction is not affected by gravity or anything else. So we use distance equals rate times time again. So our final answer, coming from distance equals rate or velocity initial in the x direction times time. So we just plug in our numbers. D equals our initial velocity in the x direction is just this. Cosine 23 degrees times 4.2. You can use negative 23 degrees times 4.2 times the time it took to get there, so times 1/2 or 0.50. So our answer is D equals 1.9 meters. So that's how far it traveled in the x direction after being thrown out the window.